Let's face it, today's consumer expect nothing less than lightning fast response time and personalized experiences. Fortunately, Mistral 7b was designed with these needs in mind. Using a combination of state-of-art NLP algorithms and advanced neural network architectures, Mistral 7b is capable of generating highly relevant and tailored responses based on user input. And because it is trained on massive amount of real-world data, Mistral 7b can adapt to new scenarios and languages quickly and seamlessly, ensuring that your chatbots remain accurate and effective no matter who is asking question. And we have seen from healthcare to finance to retail, this Mistral 7b has application across virtually every industry, which enables organizations of all sizes to stay ahead of the curve when it comes to customer engagement and satisfaction. So if you are ready to take your chatbot game to the next level, then look no further than this Mistral 7b. That is the future of NLP and conversational intelligence. So what exactly is this Mistral 7b? So basically this Mistral 7b is a large scale pre-trained language model which is developed using the transformer architecture. And its primary goal is to achieve a good balance between high performance and efficiency, which make it suitable for various use cases where low latency and lower cost are required. So unlike other popular language models like Llama 2 and Llama 1, this Mistral 7b employs specialized techniques like grouped query attention and sliding window attention, which improves its ability to reason, solve mathematical problems, and generate computer programs. Because the former method enables faster decoding times by efficiently handling multiple queries simultaneously, which reduce the memory requirements during decoding and improve overall throughput. On the other hand, the sliding window attention helps process longer input sequences more efficiently by splitting them into smaller windows and then applying self-attention computationally cheaper than traditional self-attention layers. And by utilizing these optimization strategies, this Mistral 7b achieves state-of-art methods while requiring fewer computational resources. So to understand this better, let us say you have a natural language question regarding math. Example, how do I find the root of a quadratic equation? You could feed your query into the Mistral 7b, which would then output a response based on its vast knowledge base. So in practice, you might utilize Mistral 7b within a software application or website to provide intelligent assistance to users with complex questions related to mathematics, computing science, or any domain where textual analysis is necessary. Alternatively, this Mistral 7b can serve as a starting point for training custom language models tailored to a specific business need, providing a strong foundation for future innovations in AI technology. So regardless of how it is applied, Mistral 7b represents a new standard for achieving optimal performance. Now let's understand the architecture of this Mistral 7b. So let us take an example to illustrate this Mistral approach to handling extremely long text input. Suppose you want your AI assistant to summarize a scientific paper that is around 50,000 words long. So without any optimization technique, processing this lengthy document would require a massive amount of computing resources, which will make the process slow and expensive. So here is how the Mistral could handle the scenario. First, it has a sliding window attention. So as mentioned earlier, Mistral uses sliding window attention to allow the model to consider a broader context when predicting the next word. So in our case, since the paper is so long, Mistral may use larger window sizes and multiple layers to enable the model to access tokens further back in the input tokens. For instance, W can be 8192, K can be 64. That might work well for this particular application. Then comes the rolling buffer cache. Due to the immense computational demands of this operation, Mistral employs a rolling buffer cache to optimize performance. So when pre-processing this work, the system will split it into the chunks of roughly 8 KB each. As the model moves down one sentence at a time, so each new chunk replaces the oldest one in the cache, and thus only recent accessed part of the work will stay in memory. freeing space for fresh sections without losing important data already seen. Then we have prefill and chunking. So if pre-processing the whole document is not visible due to enormous size, Mistral offers another solution which is called chunking. So instead of loading all 50,000 words simultaneously, the user breaks the text into smaller segments of approximately 400 words, fill them into the cache, and let the model generate the corresponding outputs independently. So once finished, the chunks combine to form the final results. So while slightly less efficient than filing the whole work into the cache, this method reduces cache requirements significantly, making it easier to train and run Mistral on resource constrained hardware. So overall, this Mistral combination of sliding window attention, rolling buffer caching, and chunking enables faster and more effective processing of exceptionally prolonged text input, making it a viable choice for researchers working with vast dataset. And it also opens up opportunities for application requiring large amount of written content such as search engine, legal research, or academic papers. Then comes the fine tuning and the guardrails. Now we have instruction tuning, that is we can train an already built AI model like Mistral7b with new and specific information to do certain tasks better. For instance, if you want the AI to provide excellent assistance for a hotel, so you feed it with a lot of details about hotels, and then the AI becomes good at helping guests find rooms, restaurant nearby. Then we have guardrails. So to keep AI models safe and trustworthy, we add limitations so that they don't spread lies, hatred, or violate personal rights. For example, we may tell the AI not to share any fake news, insult people based on their race, gender, or reveal someone else's private information without permission. And these limits protect society while still allowing the AI to perform well. So in summary, this instruction tuning makes the AI smarter for particular jobs, and this guardrails keeps them safe and responsible. And both are essential when implementing AI technologies like Mistral 7b. Now let's discuss the Python code to create a chatbot using Mistral 7b on Google Colab. So in this code, we are using Mistral 7b to give quick answers to questions in English, and the code will download some necessary tools like LangChain, transformers, and bit and bytes through pip, which allows us to run the program efficiently. And afterward we specify how we would like Mistral 7b to work during quantized computations. So following this, we create two variables, model 4-bit and tokenizer, where model 4-bit holds Mistral 7b and tokenizer stores its instruction. Next, we set up a pipeline named pipeline inst containing all required components. And then we are defining a function called generate response that utilizes the prompt template and LLM chain classes to receive a query, pass it to the pipeline, and then deliver the appropriate solution back. So ultimately running this generate response, that is the name one president of India, will give us the results. So for example, when we run this code, we can get the president of America is this and that. So that's all for today. Thank you.